We now discuss the solution of a problem from the section Real Analysis, and this question is related to the limit of a sequence. This question has appeared in the CSIR National Eligibility Test held on 16th September 2022. And this question is from the section C. The given question is for alpha greater than or equal to 0, define an is equal to the quotient 1 plus 2 power alpha plus so on and so forth plus n power alpha whole by n to the power of alpha plus 1. What is the value of limit n tends to infinity of an? We are given 4 options. Option 1, the limit does not exist. Option 2, 1 by alpha square plus 1. Option 3, 1 by alpha plus 1. Option 4, 1 by alpha square plus alpha plus 1. Given alpha greater than or equal to 0 and a suffix n is equal to 1 plus 2 power alpha plus so on and so forth plus n power alpha by n to the power of alpha plus 1, and required to find the value of limit n tends to infinity of an. We now discuss the solution of the problem in detail. We are given alpha greater than or equal to 0 and a suffix n is equal to 1 plus 2 power alpha plus so on and so forth plus n power alpha by n to the power of alpha plus 1, where n belongs to the set of natural numbers. Thus, we have a sequence, the sequence an is equal to 1 to infinity. Required to find the limit n tends to infinity of an. Now we take an and we write down as 1 by n in brackets 1 plus 2 power alpha plus so on and so forth plus n power alpha whole by n power alpha. Now we separate them. 1 by n into 1 by n to the power of alpha we have written as 1 by n whole to the power of alpha plus 2 power alpha by n power alpha we have written as 2 by n whole to the power of alpha plus so on and so forth plus n by n whole to the power of alpha. And this we write down in a sigma notation as 1 by n into sigma r is equal to 1 to n r by n whole to the power of alpha. R is ranging from 1 to n. So it generates all these things. Agreed. And required to find limit n tends to infinity of an. So the limit n tends to infinity of an is equal to limit n tends to infinity of this 1 by n sigma r is equal to 1 to n r by n to the power of alpha. Once we see this, this is the limit of the sum. This is the limit of the sum, and limit n tends to infinity. This is we remember the definite integral as the limit of the sum. So this is equal to integral 0 to 1 for r by n x power alpha dx. Agreed. This we have written. This is the definite integral as a limit of a sum. This is a very well known concept. Definite integral as the limit of a sum. This we have studied even at the intermediate level also. Agreed. Now we integrate. Integral of x to the power of alpha is x to the power of alpha plus 1 by alpha plus 1 to be evaluated between the limits x is equal to 0 to 1. For the upper limit, it is 1 by alpha plus 1. For the lower limit, it is 0. So that is equal to 1 by alpha plus 1. Thus, the limit n tends to an exists and its value is 1 by alpha plus 1. So let's look at our options. So our answer 1 by alpha plus 1 appears against option 3. Therefore, the answer to this question is option 3. That is the detailed discussion of the solution of the problem from the section real analysis, and the problem is related to the limit of a sequence. I am sure that you understood the solution of this problem, and I wish you all the best. Thank you.